All right, cool. So
Sure.
that if some of the folks miss this session, they can actually replay it.
Sure. So thanks, John. So just to kind of set the stage, we have this concept of virtual cloud network. And what this is really to say that what we want to enable our customers to be able to do is to be able to connect and protect different type of endpoints wherever they may be. So these might be virtual machines in your on-prem data centers. They may be workloads in Amazon or Azure. They may be telco NFV use cases, or they essentially could be in any location and actually any type of endpoints. Meaning that if you've got some brand new containerized applications, you've got even bare metal machines. We actually want to create a fabric that connects and protects all these different type of endpoints wherever they may be in your network. And then on top of that, we want to be able to give you great visibility across the whole lot. So once you have this large fabric of endpoints in all different locations, so you can imagine it is very important to actually have visibility across them all. And so we wrap up all these different endpoints in all the different locations with excellent visibility. But today, what we'll really focus on is about the security aspect and about how we're doing load balancing in a very different way, once again, across all these different endpoints and locations. So as I touched on a little bit before, the NSX platform has really changed since it's come out maybe back in 2013. Even in the last year, we've made big kind of changes or enhancements to it. And so in the past, we could always do the microsegmentation. We could also do routing, switching, different types of firewalling. But we can also do container networking nowadays. We can do software-defined load balancing. And we're adding on security. So we're adding on IPS, IDS capabilities, which we'll focus on today. And of course, this also complements our SD-WAN platform. So then, if we speak about just our firewall that we have today with NSX, so not only do we just do microsegmentation, which we've always had in the past, that was probably our #1 popular use case for all our customers. Everybody wanted to jump on microsegmentation, right? So we not only have that, but we've also layered on something called NSX intelligence. And what this is something that is able to see all the traffic across all your endpoints in your NSX firewall. And then it will help you to get the visibility and also create the microsegmentation policy for you. So that means that we're able to see all the traffic in your virtualized environment and make intelligent security recommendations about that, around that. So this will really help with those large complicated environments and difficult policy, because we can actually go ahead and automate that for you. Of course, on top of that, which is what we'll kind of zoom into soon, is IDS and IPS. And this is an amazing new capability that we have. And it's something that nobody else offers. Typically, IPS, IDS is done with physical appliances. Instead of that, we're doing this in a distributed architecture, which is aligned with our AV load balancing. It's aligned with our distributed firewall, service aware, which means that it understands your actual applications. So what services are actually running, so we can better protect them. And then last but not least, we want to actually make operating your networks easier. So for the network security and systems team, we want to make things more straightforward. So we've tried to create something that's also drastically more operationally simple. So just to touch on the microsegmentation use case that will segue us into the IPS IDS. this is a story. It's been around for a very long time, and I'm sure some of you have seen it already. So typically, a system which has perhaps not been patched ends up getting breached by a hacker, and then that malware essentially spreads throughout your data center. So then, how do we stop this? We stop it with our distributed firewall, because with our distributed firewall, every single packet going in and out of every single NIC within your virtual machines or even on containers is inspected. And we say that unless we specifically allow some traffic, well, it will all be dropped. So it doesn't matter if you have a flat network, one VLAN in your environment, and that's it. We can still protect all the traffic inside there. The other cool thing is that this is an object-based firewall, which means that we no longer need to necessarily use things like IP addresses, subnet range for the policy. We can actually base it on simple things like say the name of the VM or particular attributes or tags that we apply. So even looking at the policy, it's much more straightforward to understand and operate. So with that in mind, we've actually added to this distributed firewall by giving you IPS IDS capabilities on top. So this IPS IDS, it's not as if it's a completely separate platform. It's more like we've layered this capability into the hypervisor in addition to the distributed firewall. So back in 2017, NSX was launched. And then we actually shared, we created that term microsegmentation in the market. After that, we go to 2017. We added a lot of capabilities here around being application aware to be able to give some context to our security policies. And now what we've done is, as I mentioned, we've actually added more L7 capabilities and then layered on IPS IDS on top of this. So this is a capability that is actually baked into our hypervisors. It's not done from like a separate appliance somewhere. It's actually baked in. And then just as I mentioned, every packet going in and out of our workloads is inspected by distributed firewall. Well, now each of these packets can also be inspected by our distributed IPS IDS, and it can be managed in the same easy way as our distributed firewall. So where does it sit? Just as I mentioned, as I showed the first slide about all the cool capabilities we have with the NSX platform today. Well, on top, we can actually kind of visualize it as something that sits on top of the what's on this slide as internal firewall, which is our distributed firewall. So it's a capability that we layer on top. It's part of NSX built in. So then we not only have the normal distributed microsegmentation, we also we see it as all in one, IPS, IDS, and distributed firewalling. So this is a completely new approach compared to anything out there. So we've actually built in this capability into every hypervisor. We're able to distribute that workload of analysis. So it's not like you have one appliance somewhere in your network doing all the hard work. Actually, every single one of your hypervisors will help you to do the analysis. The other cool thing is that like traditional network appliances, they have no idea about the application. They're just looking at the traffic. For us, because it's part of our hypervisor and it's got understanding of the actual workloads running, we do have extra context. We're application aware. And once again, instead of creating something more difficult to manage, a whole separate platform, we have built it in with our distributed firewall, which means that with the same ease that you manage distributed firewall, you can actually manage the IPS IDS. And let's just do a little compare and contrast, just so everyone's very clear on what the difference is between doing it traditionally and the way we're doing it. So we'll start with this example of before you had this new distributed way of doing things. Well, what we'd have is that on the right-hand side, we've got our physical IPS IDS boxes. So this is typically a dedicated appliance, or perhaps you could have additional capabilities in your physical firewall. So you've got your separate firewalls sitting in your separate IPS IDS sitting in your environment. And what you have to do is hairpin the traffic to those appliances. So you've got to send the traffic all the way out, typically to your physical default gateway. And then from there, we loop the traffic towards our IPS IDS, and then it comes back again. So this is a problem because not only does it eat up bandwidth in the network, it adds latency because you've got extra hops, but also in terms of the actual performance aspect, those physical IPS IDS boxes, they'll always have a very specific and limited capacity because they're doing that inspection with CPU horsepower, right? They need a powerful CPU to do those deep packet inspections. So what happens is that you need to plan next 3 years or 5 years ahead for how much inspection you really need for the IPS. And then you need to purchase that today. So you'd have to go out to market and overspend and get a high performance IPS IDS box. But in the end, you've still guessed the capacity. You don't even really know for sure. None of us is able to really accurately guess in 5 years' time how much capacity we might need. So not only does this affect performance, it also adds complexity to the physical network because we have to loop all the traffic around. And then on top of that, it's also a performance issue because you may run out of capacity in those IPS IDS boxes. And then what can you do? So the traditional way around this is that only a small amount of traffic, which is regarded as like highly secure, perhaps it's payments related or has like, very sensitive data, only those type of traffics are inspected by the IPS IDS. So, and then the rest of your traffic in the environment is not protected by this technology. But we don't want to do it that way. What we've done is that we've actually taken that IPS IDS capability and we've distributed it in every single hypervisor. So since every hypervisor has this capability, it means that each workload can be inspected. All the traffic from all your workloads is inspected. So instead of having just a small amount of traffic in your environment with this protection, added complexity, and capacity constraints, we're essentially giving you unlimited capacity, and we're giving you the capability to inspect all of your traffic. So we're turning things completely upside down. You have unlimited capacity, everything is inspected, and as you add more physical hosts, then actually your performance actually increases. You get even more capacity. This means it's scale-out architecture, so your throughput is essentially unlimited. It's massive throughput. In terms of coverage, everything is inspected instead of only just the small amount of traffic. So there's no blind spots. The other cool thing is that, okay, traditionally, if you are inspecting only a portion of your traffic, you can't really move your virtual machines all over the data center because it might move away from, from that physical network where the inspection is applied. With us, because we're doing it in the hypervisor built into VMware, everywhere that you move your workload through vMotion, it's actually the actual security policy and inspection, the protection, will follow the workload. So you can vMotion your workload all over the data center, and the inspection will remain. You don't need to worry about it in terms of where it's physically connected to the network in the data center. The other cool thing we do is that since we understand what's running inside the workload, we're actually able to make things a bit more efficient. So the typical way that a physical IPS IDS works is that you've got a massive number of signatures, and every single signature is checked for every single packet, every single traffic flow. So you can imagine it's very intensive, and it's not very efficient. So what we do, because we understand what's actually running, is that we look at the application and we say, oh, well, okay, maybe this is MySQL and we've got an Apache server. So then instead of having to inspect all of our signatures, maybe 10,000 plus, instead of that, we can reduce the number of inspections down very low. Because we can say, okay, right now for MySQL, there could be like 25 or 30 signatures that are relevant. So then why don't we just inspect just those relevant signatures, which is what we're doing. So you get a massive reduction in the overhead in terms of what needs to be assessed, and of course the performance. There is performance benefits of doing this. We're able to see what type of application it is. We're able to see what server it is. Perhaps in this case it's a web server. We can actually manually do that or get the context from NSX Intelligence, which I touched on a bit earlier. And then, as I mentioned before, because we're doing all of this type of inspection with simple policy instead of complex network configuration, that policy sticks to the workloads. So even if you deploy a new workload, say in this purple network or this purple application, it's likely that you can actually have that workload just automatically inherit the purple policy. So you don't need to manually do it. You'll just say that, oh, okay, I'm going to scale out this application, add another couple of VMs. So one more purple VM appears. That will automatically grab the correct IPS IDS policy. When the workloads move around, the connections won't drop as we save the state. And then the number of stale and redundant policies is reduced because these policies are actually linked to the applications. They're not just a huge list of policies that have to exist across the environment. So as a summary, before I just show you a quick demo, you have massive elastic throughput. Every time you add a host, it's like you get extra capacity. Your physical network architecture is greatly simplified because we don't have any requirements on the physical network to do this. This is all done by us. It's taken care of by us. It's very simple to operate, and I'll show you that in a quick demo shortly. And the other cool thing is that, say today you have some workloads that highly secure require IPS IDS. Typically what I find is that you'll have a specific VMware cluster where those workloads are. Then only those workloads are hooked into your IPS IDS. Instead of that, we're saying that why don't you add that specific pool of compute into the rest of your environment, because we can inspect everything now. So actually you can make everything more efficient and flexible that way. And that's what I mean by utilize stranded compute capacity. Okay, so this is when we log into NSX, this is the actual GUI that you get. And in this case, we've clicked on our security tab and we see a security overview. So straight up, we're able to see a summary of the events that are happening, the criticality, and the VMs that are being targeted most. So you get a good a good kind of overview of what's happening. Then say if we want to look at our IPS-IDS, we simply click on Intrusion Detection, and this is essentially our management console for our IPS-IDS. The cool thing here is that if you add a new cluster of VMware, right, say Compute 05 at the bottom, since we're integrated with vCenter, to turn on this protection, it's as simple as clicking a button. So all I need to do is slide that button over to enabled. And what will happen is that the appropriate bits of software will be installed on ESX hosts in that cluster, and the inspection will be turned on. It's tightly integrated with NSX and vSphere. So it means that all it takes is literally to click that button and the inspection will be turned on. So then if we take a look at the rules, how straightforward it can be, it looks like your typical type of firewall rule set. But the cool thing here is if we look at the source and destinations, we can actually click on these, which are groups. So instead of having to do like complex IP addresses and subnets for all of your source and destination in your rules, you can simply create a group. And if we look at the members of this group, we can see that in this case, there's a bunch of web app and database virtual machines. We're able to see the IP addresses for those machines. And here is a definition. So how did those machines drop into the group? Well, I created a simple policy that says every VM with a tag that says web or a tag that says DMZ drop into the group. So basically all my web servers or anything in the DMZ will automatically drop into this group and drop out of it. So there's no manual configuration when adding or removing VMs to this policy. So I'll close that. Now, let's take a look at the events. So if we look at the events, we see a timeline of the events. And of course, the larger circles and the red events are more critical. And if we zoom in on, say, one of these, we can see that, you know, what type of vulnerability it is. In this case, it's related to Oracle WebLogic. Got 28 VMs affected. If we click on that, we can see the source and destination and some details about the number of events. And the other cool thing here is that actually we can, in one click, we've identified the CVE, which is the vulnerability definition. And if we can directly click on that and then understand all the details of the vulnerability and work out how to immediately resolve it by a particular update to the WebLogic software or so on. Okay, so the next use case that I want to touch on is we call it federation. So I'll quickly run through this. So essentially what we're able to do is that we have kind of a manager of all our locations. So say you've got 4 locations in this case. They could be spread across your DC, your DR, our VMware Cloud on AWS, and so forth, Amazon or Azure. So we want to create consistent, easy to manage policy across all of those places. So then the things that we can do is create that consistent policy across all our locations, make your DR more simplified, or if you've got active data centers, make the policy easier to manage. So essentially what we have, we call it a global manager. So the administrator configures into the global manager. The global manager pushes that config down to each site. And this is for the firewall policy, microsegmentation policy. So then in terms of a DR, what would happen? What will happen is we have our active on the left, our DR on the right. So say our active data center goes down. What will happen is that we can just fail over to the secondary site. So our standby manager becomes active. All our workloads are moved across. This can be done by SRM or similar technologies. And then we're good to go. So we're really simplifying the security policy when it comes to disaster recovery and just taking some of those manual steps away. The other cool thing is that for our active data centers, which we're referring to here as metro pooling. So if you've got 2 or 3 or 4 active data centers, then actually you can have just one place to manage your networking and security. So we pool all of your compute and network resources, manage it from one place. If one of them goes down, once again, we're able to protect that with the other side. The other cool thing that I'll touch on is network detection and response.
Hey, Aru. Yeah, I think probably we look at the questions. There's some questions around the IDS, IPS.
Yeah, do you want to field the questions? Because if I stop
let's have a second.
Okay, because I won't be able to field the questions and and share this at the same time.
I mean, there are people that are asking around the IDS, IPS, whether it create a high latency.
Yeah, so performance-wise, there's no impact. And actually, compared to physical IPS, IDS, you'll find a massive improvement in performance because we're doing the inspection inside the hypervisor. With a traditional IPS, IDS, you need to add many extra hops to the network and loop the traffic around, hairpin it.
Yeah. So the other questions will be, what are the sources of the IDS, IPS signatures database updates?
Okay, so the sources, we pull it down from the vendor, or we can actually download and upload it to NSX Manager ourselves. So it can be either done locally or automatically. So by default, it's automatic. So.
Okay, that's cool. I mean, there's a questions around that when they enable the IDS, IPS, the high latency actually increase. I think probably to this guy called Soknaran Chong, probably drop me an email, right? It shouldn't happen in this type of scenarios. I'm not sure what exactly went wrong. And
yeah,
like Aru mentions, right?
There shouldn't be any performance problem like that. So there's probably something wrong in the environment. So that one we can definitely talk about another time.
Yeah, exactly. So there's another questions around, I mean, this is pretty long. It's from Ingram's Tamo Khan,
sure.
Pakistan. So his question is that we usually hear from our partners that customer challenge them that how reliable is their NSX IPS is comparing to the top cybersecurity company like Cisco, Fortinet, Palo Alto, etc. Where they have dedicated team in the cloud working as red and blue team to find out malware, hashes, and stuff like that.
Of course. So we actually get our signatures from industry standard place. So this is not, in terms of the signatures, there will be no difference between us and really anyone else. But in terms of that red team, in terms of the red team, blue team, all of that type of stuff, that's what I'll actually touch on right now. So of course, IPS, IDS is one thing, right? It's signature based. But if we're talking about those advanced 0-day type of threats, this kind of conversation, then actually your traditional IPS, IDS will not satisfy that. And built in with NSX today, we actually have network detection and response solution. So last line, which is absolute like next generation, like latest technology of network detection and response, is actually part of VMware now and is being integrated with NSX. So this kind of addresses that question that's being asked, and it's addressing it, I guess, in all the points of that question, right? So we actually have advanced researchers looking into all of these type of threats. We're able to do sandboxing. We're able to do work out anomalies in the network. So if there's some type of strange behavior that's not normal, we can figure that out automatically because this is powered by AI. So we have emulation, meaning that we actually have a sandbox type emulation of the actual code that's being run in the network. So we can run that in the sandbox and really pull it apart and work out what's wrong. And so we have that type of threat intelligence, threat hunting team that was mentioned before. So I won't spend much time on this, but actually, if you have time, you can look up Last Line. It's now part of VMware, and it addresses all of those concerns. It's the absolute like gold standard in network detection and response today. It leverages AI. We can even do things like SSL decryption and inspection as part of this, and this will apply to all of your workloads, whether they be containers or VMs as well.
Yeah, I'd just like to add on some what Arudi mentions. Right, if you look at the traditional way of how we size up the IDS IPS, it's a physical appliance, and it's almost impossible to get the real data, the real throughput that's required for all the applications that's run within the data center itself. That's the reasons why most organizations, most customers will not going to turn on the IDS IPS for the entire data center, because they know the moment they enable IDS IPS for all applications, all workloads within the data centers, you're going to increase that latencies very, very much. And the way of how we're going to do it is very different on the distributed model. It distributes into every single workload. That will actually is not going to create those latency that you see in the traditional appliance. So back to Aruk, there's another questions around how much of CPU memory they will consume if they're going to turn on the IDS IPS. What are the resources that need to spare for it?
So that one, because it's done within the hypervisor itself. You don't need to size extra for the IPS IDS. You've essentially got unlimited capacity. It doesn't make a hit on the sizing. Just like say for today, in terms of distributed firewall, it's the same thing. We actually don't size for distributed firewall because it's a negligible impact on the hosts. So that's also not something that you need to really be concerned about, because we're not adding, say, an extra VM that's doing the inspection on each host. It's actually a hypervisor process that sits alongside distributed firewall.
Yeah, so I think leveraging on things like VROps, right? You can, just like how you look at the host utilization versus the VM workload utilization. So as long as your CPU memory goes up to a certain level, this is where you either scale up by adding more CPU, more memory into the host, or you buy additional hosts, right? It's very unlike the traditional way how you size up the IPS, no longer required to understand the total throughput required within the data centers, right? As and when you're running out of CPU memory within that host, either you work certain workloads out from that box itself, the host, or you buy additional memory CPU, or you buy additional hosts, right, to reduce down that utilization. Right, and I think the last question before we move on would be, what does LM stand for in the topology? I think I missed that slide.
That's local manager. So that's just local manager and global manager. So essentially in the federation use case, say you have 2 data centers, each of them will have their own local manager, and there'll be a global manager that is residing over both of them. So the global manager, when you do a configuration change in there, it's pushed down to the local manager.
All right, cool. I think that's all we have. All right. So,
awesome.
For all the attendees, get us the questions, right? We'll try to address it when we come to the right sessions. I think there's some RV Networks questions. We're going to leave it until the end of these sessions.
Sure. So, so essentially with the network detection and response, I just included like one easy screenshot here, where you can see that we actually understand the type of traffic and the traffic flow between different workloads in your data center. We're able to work out what threats are there and which stage it is in the attack, And this is, yeah, I mean, it's essentially the latest generation of network detection response from last line. So that's also something that we cover with NSX. So moving on to the software-defined load balancing. So around, I guess, a year and a half ago now, we acquired RV Networks, which is an industry-leading software-defined load balancing. And that way and because of that, now we have integration with NSX and RV, and we have, an industry-leading software-defined load balancing solution. So then, what's the challenge that we're trying to solve, and how are we differentiating? To understand that, first I'll do a short discussion on the challenges of using physical boxes to do load balancing. So firstly, physical load balancing means you need to buy specific hardware from load balancing vendor. So then if you need any update to that load balancer, or you need to add capacity, it's really tied to the hardware. You have to go and purchase and rack and stack that hardware. Then each of these devices is essentially managed individually. In terms of monitoring and management, it's a challenge. You have different silos of essentially pairs of active standby load balancers to manage. The automation, these load balancers from all the other vendors, they were never designed with modern automation in mind. That automation capabilities they have is kind of stuck on top. It's not built in. Since what we have is an absolute latest technology built for modern applications, we have built-in automation capabilities right from the start with modern apps in mind. So the huge challenge with physical load balancer is around telemetry. So you can imagine like this: when say I'm a physical load balancing vendor, and I create an appliance, and I'm thinking about performance. All of the actual performance that I'll put into that box, I'm going to dedicate to load balancing. So I can say, okay, I can handle 50,000 connections per second, and that's linked to the CPU I put in this box. So the performance is all dedicated to load balancing. This poses a problem. The problem is that if you want some type of telemetry to be able to do analysis of a problem, for example, then that actually requires CPU resource as well. But your physical box, all the performance is dedicated to the load balancing function itself. And this is the reason why that from the physical load balancing vendors, the analytics is very, very poor. In terms of visibility, analytics, troubleshooting, it's very poor because all the performance has to be dedicated to actually doing the load balancing. And in terms of capacity, so the physical load balancers are always active standby, right? So essentially, as a minimum, you'll have like 100% over provision capacity, which I'll go into in the next slide. So say today you go out to a hardware vendor and you say, let me buy a load balancer. And for maybe the first 2 years, I'm going to use 15% capacity of it. Then actually it's worse than only using 15% because you've got a standby unit as well. So you've essentially bought like 185% of the capacity you need right at the start, because it's active standby. So then as your environment grows onto multiple sites or multiple departments, then this problem gets even worse. So what you find is that in any environment, the larger it gets, there's huge wasted capacity from physical active standby load balancer pairs. The other challenge is that capacity management, because we're just adding pairs of active standby load balancers as capacity runs out, you have to manually work out, okay, which of these load balancers will I put my virtual IP on? and it's stuck there forever. It'll be very hard to change. Right? So you've got like your virtual IPs or your, the entry point to your applications is stuck in a certain part of the physical network and is very difficult to move ever. So you over provision the hardware and you're stuck in terms of where your applications are actually accessible from. And of course, all of this is operationally complex because you've got a whole bunch of individual pairs to manage. And it just doesn't make sense for modern environments, which could have containerized workloads. They could be on public cloud, hybrid cloud environments. This physical type of active standby setup with very little automation and very little analytics makes no sense for our modern applications. The next challenge, what about public cloud? If you are looking at deploying some apps in the public cloud, you might be thinking, well, if I go to Azure or if I go to Amazon, well, they do offer some load balancing services there. That's true. So in terms of automation, it's great. In terms of scale, they're awesome. But actually, they're focused on those two use cases. So if you look at our cloud vendors like Amazon, Azure, their load balancing service, it's really focused on scale automation, not on features or performance. And because of this, you need to add on extra tools onto those load balancing services to give you that same experience that you require as you've had on-prem. And then say these two examples, Amazon, Azure, they do their load balancing and the additional tools in different ways. So then your network team has to not only manage your on-prem load balancers, they have to be able to understand how to work with the Amazon flavor, also the Azure flavor. So there's no consistency between different clouds or on-prem. And of course, the visibility is limited across all of it. If we go and deploy like a virtual edition of, say, an F5 on the public cloud, then the features are there, but the automation or the scale is not there. So everything here is kind of mismatched, right? It doesn't make a lot of sense. And that's what we're trying to solve with our software-defined load balancing solution. So just like any SDN, we've separated the control plane and the data plane. So the controller is where we do analytics and all our configuration, and it controls all the deployment of our data plane. And then what's actually doing the load balancing are our service engines. So the service engine is what's doing the actual load balancing, where the virtual IPs are hosted, and they can be deployed anywhere, and they can be scaled up and down as you wish. So we've got that separate control and data plane. You can, from one controller, you can deploy your service engines anywhere you wish. They can be on bare metal. From one controller, you can have service engines on bare metal for VMs, or even in multiple public clouds. So you get that consistent experience. And because we've separated our control plane and data plane, we've got excellent analytics and intelligence. Because our service engines are doing the heavy lifting, all the actual load balancing, but our controller is where we're doing the analytics. So we also have unlimited capacity to give you all that valuable analytics. So to start with, the first use case that we handle is just straight up load balancing. Right? That's what we're all kind of used to. We can do for VM, container, across any type of environment. Second use case is WAF. So this platform does have WAF built in. And the third use case is container ingress. So we can actually do ingress control for microservices environments. And I'll share these slides after, but this is just a one-pager for your reference, just to show that we are covering most of the use cases or all of the use cases that you'd require from your load balancing platform. I'll show a short demo on this later on, but essentially, because we've got that advanced analytics capability, we're actually able to give you great insight into, say, the security posture of your apps. So we can immediately show you, do you have a DDoS attack? What about your ciphers? Are they new? Are they old? Do you have particular applications that have out-of-date ciphers? And we can just overall give you a security assessment score. So you can take a look and be like, okay, this is not the best. Let's look into it. Maybe we need to upgrade the ciphers on some of our applications. This one I'll go through a live example to show you how this works in terms of troubleshooting a problem. And since we're big on automation, right from day zero, we're actually helping you to actually deploy the virtual services, and day one onwards, we can actually have automatic kind of scale up, scale down, lifecycle management automation. It's completely different from your traditional hardware load balancers where everything is manual. And if you've got different departments or different tenants, then we can also, instead of having a fixed hardware capacity of active standby load balancers, you can actually have your one place to manage everything from, and you can deploy one service engine per department, for example. So it becomes very flexible. In terms of upgrades, you can do even partial upgrades on the environment instead of upgrading one pair of load balancers affecting the whole environment. And so we essentially solve the shared services model challenge that we have with the physical deployments. So essentially what we're trying to do is, instead of having a bunch of different siloed solutions on-prem or in multiple public clouds and stitching together different type of automation and monitoring services, we're giving you a much easier platform where you have a consistent platform across all your different locations. It's simple to operate, and we wrap that up with excellent visibility and analytics. Now I'll just touch on GSLB. So I only got 2 slides on this, but in short, we also built in GSLB capability into RV networks. So essentially we have, if you have multiple sites, then the use cases that we can do is active-active, active-passive, even geographic location-based load balancing. And the awesome thing is that that really smart analytics that we have, it also applies across multiple sites. So this essentially, if you're familiar with F5 terminology, the GTM and LTM, actually our platform, it covers the same capabilities as your GTM and LTM. So last but not least, before I show you the demo, is that we also build in WAF. So we not only build in the GSLB, which covers your GTM, LTM, but we also have WAF built into the platform. And of course, most of us would know that, well, whenever there's attacks, they're typically on a web application, right? And the reason why WAFs have not been very effective is because of complexity. So WAFs are notoriously hard to configure. They're heavy on resources on the actual physical appliance, so the performance is poor. And then from a visibility standpoint, it's very hard to know what's actually going on. So this is the things that we've tried to solve. So essentially how we solve that is that we're able to automatically learn the traffic flow of your application and whitelist it. So if you've got application in your environment, we can put it in a learning mode, learn the expected traffic, and block everything else. And this takes very little resources on the platform. On top of that, of course, we're able to get the deep visibility into what's going on and fine-grained logging, which is not possible on a physical appliance because, once again, they'll have performance constraint. And for us, because we have essentially unlimited performance, because we can scale out those service engines, we're not limited in our inspection capacity. So essentially what we do is that we have a learning engine. It understands your application traffic flow. We can whitelist your known good applications, and only what is not whitelisted will be inspected, thereby doing things a lot more efficiently. So I'm just going to share my screen to show you how this looks. Okay, so when we log into Avi, this is what we see. So essentially, you know, we've got like a dashboard of our applications, our virtual services, and I'll quickly just run you through a really awesome example of the way that analytics can make our lives a lot easier. So say in the past with your physical load balancer, if we have a problem with application, the first step is usually to do a packet capture. So straight up, you need to do a packet capture, and someone needs to analyze that manually and take a guess of what could be wrong. And this can take hours or days. Instead of that, let's take a look at an example here. So I've clicked on one of my virtual services, and you know, we can see a kind of breakdown of the traffic and the response time. So you can see that, well, you know, there's certain spikes in time, but yeah, overall, the performance looks good. So then let's take a look at our logs. So the platform, it actually will analyze the logs and show you what is like significant, not significant. So you don't need to manually take a look at this. So then in terms of, let me, because this is actually a live environment which we actually just pump through random traffic, right? So let me try and find a log that will be interesting for us to look at. So you can see I'm just like zooming through and just taking a look at, you know, the traffic that's been sent through recently. So then in this case, if we look at say this log, so straight away we're able to see the spikes in logs, right? So we see that most of the time actually the response is pretty good. And this is end-to-end response time, right? All the way from client to the server. But what about this guy? 699 milliseconds, pretty long. Not sure what's going on there. So then if we zoom in on that, and I haven't actually pre-prepared this, so I'll run through it just as you would if you're looking for the first time. So we can see that actually, well, it's someone in India, and they're actually trying to get to the load balancing service. The round trip time, and this is based on the actual frame headers, so it's actually able to see the real time that's taking, is 697 milliseconds. So straight up, say for example, you get some complaint from this client. This client is saying, oh, you know, overall, it's just taking a long time to access this website. And there's something wrong. Can you tell me what's wrong? Something's wrong with your service. Straight away, we can actually identify that it's actually the round trip time between the client and the load balancing service, just purely because they might be in completely two different countries, right? But if we go further down, we can see that between the load balancing service, so Avi, and the actual server, these are probably located within the LAN. We can see it's less than 1 millisecond. In terms of the app response time, the app response time is actually like less than 1 as well. And in terms of the data transfer, it's less than 1 millisecond. So immediately you can zoom in on a particular problem log, and you can immediately work out, well, what the problem is. Like it could have been something else. Perhaps it could have been the data transfer is taking forever. So maybe, you know, it was a spike in storage latency at that time. But in this case, it's clear to us to see that actually the round trip time between the client and the load balancer is long. But yeah, I mean, in fact, the rest of our performance in our environment is great. And between the load balancer and the server, it's great, less than 1 millisecond. And so I just wanted to give you kind of a quick insight into understanding how this can actually help your operations make life a bit easier. The other thing is that in this environment is actually for WAF, and I'll just point out that in this case, the WAF has actually matched and actually blocked this request. So you can immediately kind of see that you know, the WAF has actually matched the transaction and said that, sorry, you know, this isn't allowed. So I'll stop there and maybe try and address any questions or comments that people have since we're on the hour. Okay, so I'll just address one question here from Nam asking, can we remove traditional firewall for pure VMware-based infrastructure? The answer is that you typically still need your perimeter firewall, so the one that's facing the internet. However, all the internal firewalls we can definitely replace, correct?
Hey, there's a questions around the RV. So the question is, we have two sites, like the primary and DR.
Yep.
And RV service engines are deployed on the primary sites, and how many primary sites? Somehow the primary sites are down, and VMware power on the DR. What's the recommendations of the RV? Either new deployed on the DR or standby RV should be on the DR.
Okay, so let me share one slide to help to illustrate this. So then I'll just bring up, so if it's multiple sites, let's make an assumption that it's where we're doing GSLB. So the way it will look is, okay, so if we take a look at this slide, and we're doing GSLB, what will happen is that actually each data center will have controller deployed in them. And there'll be one that we refer to as a leader. So that guy is essentially taking the configuration and it's pushing it to the follower controller, or the secondary controller. So in the case that your data center one goes down completely, it's not a big deal because the second site will just take over and all the configuration is synchronized already.
All right, and there's another question that, since you talk about the GSLB, can you show us the demos about RV GSLB?
Well, we don't have the demo for GSLB set up. But actually, it would not be a very exciting demo, right? Because essentially the way it works. So for any vendor, actually, the GSLB, you can think of it just as a DNS server. So all we're doing is actually resolving the DNS to a different IP address. So from RV, we'll know that site A is down. So when you go to, say, google.com, it will just send you to it will resolve google.com to an IP address that belongs to the second site. So that's the basic use case of GSLB for HA. Or you could say, let me load balance round robin one address. Say you're trying to load balance google.com across 2 data centers. Then it will just direct users to one IP and then the second IP on the second site. And do it with a particular algorithm. So it's not, the GSLB use case is, you can just think of it as like an automated DNS service, and that's consistent across us and the other vendors. Right?
There's another question. Can you briefly explain WAF, GTM, LTM terms?
Sure. So WAF is Web Application Firewall. So it's different from the firewalling we do inside the data center. It's something that is basically always done from load balancer side. And essentially it's looking at web application vulnerabilities. In terms of GTM and LTM, these are actually F5 terms. It's just that most of our customers are F5 customers in the past. And so that's why I use GTM and LTM. What they mean, GTM is Global Traffic Manager, and LTM is Local Traffic Manager. What they are is that the GTM gives you the GSLB capability, and the LTM gives you the normal load balancing capability inside the site. For us, we don't have such terminology. We actually have the GTM and LTM capabilities is built into the platform. So it's not two separate things for us. We provide it. It's there built in.
All right, I think before we continue, there's a questions around NSX-t. Does NSX-t provides a real-time network traffic flow, not just layer 4 alone?
Real-time traffic flow. Okay, so I'll answer the second question first because I'm not sure about the first one, which is, does NSX-t provide the topology? Yes, we actually have, and we've enhanced it recently. It's actually built into NSX-t. There is a very nice topology feature that can show you the routing, the firewalling, and the different how the different workloads are connected. So we do provide a topology feature. And the network traffic flow, I'm not sure.
Yeah, me either. I mean, with Tamo Khan, not sure whether we understand your questions correctly. Probably you can actually put into the comment again, what exactly do you want to see from on the visibility part? All right, I think that's the questions that we have for now.
Okay, awesome. Okay, so as mentioned, I mean, this is just each of these topics you can talk about for a very long time, and they're all interesting ones to discuss and deep dive into. So in the time we've had, and without letting it drag for too long, I just hope I was able to give a quick snapshot and overview and create some interest around all the new capabilities that we have. There is even more new capabilities there, but these are some of the really cool ones focused on security and software-defined load balancing. So I hope it was informative session for everyone.
All right, probably gonna wait for, another 5 minutes if there's any other questions. I mean, you can unmute yourself if you want to ask the questions, or probably you can drop the question under the Q&A session.
Sure.
So while waiting for the for any questions, right, for anyone to ask any questions, I think just to summarize this, I mean, for many of our partners, which is not from the networking and security background, what I will actually tell you is, right, it's just like probably 10 years ago when you first look into the server virtualization, you have doubt on whether the server can be virtualized, or the benefit of this virtualization. And in fact, I mean, the benefit of virtualizations just move on from the server to the storage, and now we are pretty much talking just on the network and security. I would think, right, in the very short terms, just like how our customers react on the server virtualization, no one will want to deploy the workload on the physical machine, right? Everyone would want to do the server virtualization, want to go with that cloud journey. And now the only things that's not transformed in most of our customers environment would be the network and security. So pretty much we are trying to simplify the whole architectures for the customers. With the simplification that we introduce into the customer environment, you see the reductions of the TCO, the CapEx as well, OpEx tremendously. Now we are here to help you, to help your customers to be more efficient. There's many ways to deploy network security, and the worst part is that today, if you look at how the traditional networking and security, the physical appliance being deployed, it will definitely not gonna solve the problems for the customers, especially when they are looking into this multi-cloud environment, a hybrid cloud environment, including things like containers, the modernized application as well. So this is, if you ask me, I mean, you're all our partners here, right? This is one golden opportunities that we want you to ride together with us, right? In the very short terms, we're looking at to 6 months, 1 year, or 2 years down the road. These things will scale, right? The customers will really want to come back and buy more license, right? Buy more NSX with us when they understand the power of this network and security virtualization. So there's another questions from Chong.
Yep.
Yeah, GSLB, that's how many sites it can be supported?
Sure. So actually, I don't know the upper limit, but this is designed for, like, I've never seen a deployment where the limit is reached. So you can just make assumption that however many sites you have, it will be supported, because we have some massive customers, like some of the world's largest banks and other financial institutions that are using this across many sites globally, across many countries. So for now, let's make an assumption that for customers in this region, the number of sites will be likely to be very low compared to the actual limit.
All right. So I mean, probably for Chong, just drop me an email. So we can actually follow up with your questions later. And then, I mean, we certainly will have that maximum number of sites, I believe. It's just that we don't have it right now with us.
Yeah, it must be documented somewhere in the maximums. It's just something that's not, we never reach it, and never really comes up. Yeah. Typically, the customers tend to have a maximum of like 4 or 5 sites, but you know, it's.
Yeah. So again, right, just to re-emphasize about the power of the software-defined approach, we are bringing all these network and security services, the load balancer services, nearer to the application. So when you have that architecture is being defined, you will see that we address a lot of happening issues, right? The high latency issues with the customers today, right? Technically, there's no way the customers will really want to go back to the traditional way of how they deploy the physical appliance. And in terms of financially, right, these things scales along with your compute, with your storage as well. So unlike today, when you buy a physical load balancers or physical firewall, IDS, IPS, you need to forecast the next 3 years down to 5 years kind of throughput, right? And we talked about that is really impossible, right, for anyone to get that exact throughput for the next 3 years, 5 years down the road, right? What we are doing is guesstimates of what they are doing right now, and hopefully whatever they're buying will be sufficient for the next 3 years and 5 years, right? But when we look at how VMware is doing this with the NSX security as well as the RV network, it doesn't really matter, right? Because you don't actually do assignings. There's no single appliance to deal with, just like how you deal with the IDS, IPS, the securities, your load balancers today. So everything will be distributed, including the RV networks. So we can have one RV for one application, and if anything goes wrong with that applications, the RVs will go down together, or anything goes wrong with the RV, we're not going to affect the rest of the applications. So this is the real power of the software-defined approach.